Hey everybody, it's just me this evening. I'm Kurt Spivey, your planetarium engineer at the Ward Beecher Planetarium. My students have gone off on winter break and I am flying solo tonight. Our last Keep Looking Up of 2020 is this week. We're calling it the Circle, the Solstice, and the Great Conjunction. I hope you guys enjoy it. Just so you know, unfortunately, because I am flying solo, I won't be able to see any of your comments in the comments section on Facebook. So you'll, if you leave the comments, we'll be happy to get back to you over the next few days as you watch this as well. Just so you know, as I mentioned, this is the last Keep Looking Up of 2020. And just as we do with our public shows when we are in the planetarium, we will be taking January off as we start up a new semester at YSU. So look for us back again in February with Keep Looking Up. So with that, it's going to be a little bit shorter tonight because I don't have anybody to interact with, but we are going to start with our look at the nighttime sky. So I am going to come to this one here and share, and I want to make that full size. There we go. And we are going to take a look at the nighttime sky. This is actually a little bit late tonight. This is 11:30 this evening. There's a reason why I'm starting at this time, and we're not going to finish up here. These are the skies over Youngstown. And as you look up there, I can zoom out a bit, and you can see several things in the sky. One thing I do not have up yet are what direction we're looking. So we're going to start with that. I'm going to put that up. You'll see we are facing north to begin off with. And just as we do every show in the planetarium, since you don't have this big N in your backyard, we have to figure out how to do this with just our eyes. And we have an object that will do that. It's right over here. We have 3 stars that make a handle and 4 stars that make a cup. And I'm sure I have lots of planetarium veterans out there. That is the Big Dipper in the nighttime sky. And if I just hit 1 star there, I can show you that it looks like this. It's part of Canis Major, the Big Bear in the nighttime sky, and forms those stars up in the sky. And you see he's kind of standing on his tail at 11:30 this evening. He's pretty low in the sky before that. But it's a very important pattern to be able to see in the nighttime sky because these stars are bright enough that even when you're around the light pollution of a city like Youngstown, and just so you can see, I can make you see the stars without the light pollution, put that back on, you can see them a little bit better. Actually, I can also do that because this is more like what our skies look like around Youngstown. We're going to leave that off though, just so you can see. But what we're going to do is take these 2 stars at the end of the Big Dipper's cup, and we're going to draw a line from the star at the bottom of the cup through the star at the top of the cup, follow that across the sky. And the next bright star you're going to come to is right there. That star is called Polaris, which you know better as the North Star. We had this discussion with our last Keep Looking Up. It's not the brightest star in the sky, but Polaris is part of the constellation of Canis Minor, the Little Bear, which is also known as the Little Dipper. I can zoom in a little bit so you can see that a little bit better in the nighttime sky. And the entire sky appears to rotate around that one point. So that makes it the most important star, even if it's not the brightest. As a matter of fact, it barely makes the top 50 number of stars. But since it's always at that point and the whole sky looks like it revolves around it, that means you can, if as long as you find the North Star, you can always find what direction you're looking. Also up here in the nighttime sky, we have a very distinct M shape in the nighttime sky. This is Cassiopeia, the queen in the nighttime sky. And she is also very easy to see up there as well. Very much like the Big Dipper, she is always going to be up in this part of the sky. She never sets. And when you're around light pollution, she is bright enough you can see it, that constellation, no matter what time of the year you're looking up there. Now, like I said, there is a reason we chose this time of the night to look up at the nighttime sky. I'm going to move us around to the southeastern sky. right about there. And we're going to come in. And I know there's snow on the ground outside. And unfortunately, here in Youngstown, it does mean we get some serious cloudy skies a lot of the time. But we astronomers really do love the winter sky. As you look up there in the nighttime sky, you'll see not all the stars are the same brightness. They We astronomers actually rank stars by how bright they appear in the sky. The very brightest stars we call first magnitude stars. There are 26 of those in the entire sky. That does mean, getting back to Polaris, that it's not a first magnitude star. It actually falls in the next rank, which is called second magnitude stars. For your future reference, the dimmest stars that you can see around light pollution are down around third magnitude, maybe a tiny bit lower if you have some decent skies. And the dimmest stars that you can see with your eyes without the use of a telescope or a pair of binoculars are around sixth magnitude stars. But getting back to the first magnitude stars, as I said, there are 26 of those in the entire night sky. Now, some of those we never see here in Youngstown. They remain below our horizon at all times. Others you only see in the fall or the spring or the summer. But out of those 26, we've got 9 of them right here in a big ring of the sky that we call the Winter Circle. And the Winter Circle is easy to find because it contains probably the easiest to spot constellation in the entire night sky. He is right here. This is Orion the Hunter up in the nighttime sky. And Orion is easy to spot because he has, I went too far. Back that up a bit. He has these 3 stars right in a row that make his belt. It's the only spot in the sky where there are 3 stars that bright right in a row like that. They're called Altanach, Altanam, and Mintaka for future reference. Those are all second magnitude stars, by the way. When I was little, the first thing I ever remember seeing in the nighttime sky was those 3 stars. So he is easy to pick out. Orion is home to 3 of those first magnitude stars I was talking about. The brightest of the 3 is this whitish blue one down here. It's called Rigel. Now, while it was the ancient Greek people that named Orion and most of the constellations that we use today, there was another astronomer who lived in Saudi Arabia about 1,000 years ago. His name was Al-Sufi, and he named a lot of the individual stars, including the belt stars there. Those are all Arabic words. Rigel is an Arabic word that means left foot. So that means this is his left foot, so his left leg is here. His right leg is here and ends in a bright star called Safe, as you can see there. Not the kind of safe you put money in. Safe in Arabic means sword. They thought he had a big scimitar hanging down from his belt right here. That's a second magnitude star as well. Orion's left shoulder is marked by this star up here, which is called Bellatrix. And he's holding a shield up in the air in his left hand right here. These stars right here form a shield. He has 3 very dim stars for a head here. Then he's holding a club up in the air right here. And the arm that holds up the club ends in this bright red star. And I'm sure you've heard of this one before. It's called Betelgeuse, which roughly translated from the Arabic means armpit. And just to prove that to you, let me find my constellation art, which I believe I had to do this. Oh, there it is. Constellation art is R. And there he is right there. Orion's left armpit right up there in the nighttime sky. So between the belt stars in a row and the 4 stars bounding around, he is easy to spot up in the nighttime sky. Now, while I have this close-up view of Orion, I do want to show you he does have a sword hanging on his belt right here. And you'll see there's 1 star tucked right up here. And then there are 3 bang, bang, bang right in a row down below. Let's zoom in on that middle one there. And you'll notice that isn't a star right there. That is actually an area where new stars are forming. That is known as the Great Orion Nebula. That is the nearest star forming region to the Earth. And this is the word nebula in Greek means cloud. And this is an area where new stars are forming. Now, with these fancy astrophotography pictures, it looks nice and bright. It's lit up because some stars have begun to burn inside the cloud, and it's causing the rest of the cloud to light up. It looks red and purple when you take pictures of it with time exposure photography in a telescope. But you can see this with just your eye on a clear night, even if you are in city lights. It looks faintly greenish to your eye, and it's just a fuzzy patch right up there in that part of the sky. Now, since Orion is so easy to see, I use him to move around and find the other stars of the winter circle. What I do is I look around for his belt. I'm going to move in a little bit so you can see there. And then I move down to Rigel. And from Rigel, I come up this direction to another bright star right here. This star is called Aldebaran. And Aldebaran and Betelgeuse are easy to mix up. They are about the same color and the same brightness. This is our fourth first magnitude star, by the way. The word Aldebaran means eye of the bull or bullseye. That's because we find it in the very distinct and very famous constellation of, oh, that's not what I wanted to do. Let's see. No, still not working. But that's Taurus the bull right there. Maybe I can do it with this. It likes that. Taurus is really easy to find because around Aldebaran, you will see this distinct V of stars here that we call the Hyades. And if you see the Hyades, you know it's Aldebaran you're looking at and not Betelgeuse down here. Now, let me see if I can get that art. Well, it's going to show me all the artwork. You'll see they draw him as half of a bull here. There's a good reason for that. Here's how I picture Taurus up in the nighttime sky. The V of the Hyades is his face. Aldebaran, of course, is his eye. Taurus has one big old nasty horn that comes out like that. One big old nasty horn that comes out like that. So he's got this really big ugly head here, and he's got this really tiny, scrawny little body back over here. The three pathetic stars are the front legs, and these three even more pathetic stars back here are the back legs. I know it's not much, but one does what one can with what one is given in the nighttime sky. Now, Taurus is also home to another very distinct group of stars. It's up here above the bull's back. This is a little cluster of stars called the Pleiades. Yeah, I know. Pleiades, Hyades can get confusing. You can also remember the Pleiades by another name, though, that is the Seven Sisters. And they're called that because if you've got really good eyes and you're at a really dark location, you may see seven stars there. Actually, it's very hard to see that seventh star. Most people see six. I have really bad eyes. I see five usually. But if you take a telescope or a pair of binoculars and look at the Pleiades, you'll discover there's over 250 stars packed into that little section of sky up there. And the reason they're so close together is those are all newborn stars. They formed in a cloud of gas and dust like the Orion Nebula, and now they're gradually drifting apart from one another. While we're close up here, I do want to point out that this star right here is called Merope, and I have a little noisy cat that might join us a little bit later. That's the star she's named after. So now, when I say they are newborn, that is a relative term. These stars are still several million years old, but that's actually on the young side for a star. By the way, you might know the Pleiades by a third name. That is their Japanese name. The Japanese people call those stars Subaru. And if you see the logo of the car company, it is a picture of that logo. And just so you can see, there's Merope right there. She had to come in when I mentioned her name. That's good. Anyway, so we're going to come back down here while Merope complains a little bit. And now we'll continue our way around the circle. We started with Rigel. We came up to Aldebaran. Now we're going to come up to the star that's nearly directly overhead at 11:30. This white star is the fifth first magnitude star in our circle here. It is called Capella. And we find Capella in the constellation of Auriga, the charioteer. Now you'll notice that isn't much right there. I'll show you what I think it looks like a little bit later. The ancient Greek people thought this looked like a guy holding a goat. Matter of fact, the word Capella actually means little she goat. Don't ask me where that came from, but what is a charioteer and what is he doing up in the nighttime sky? Well, back in ancient Greece, when they were naming all this stuff, they didn't have sports like football or baseball or basketball. By the way, congratulations to the Big Ten champion, Ohio State Buckeyes. I had to get that on there too. They didn't have sports like that though. Back in ancient Greece, they had chariot races, and you've probably seen chariots before. Those are those little two-wheeled wagons that are drawn by horses. They used to race them around ovals, so I guess that kind of makes it like NASCAR today. But in any case, the charioteers, the guys who race those chariots, were their big athletes. So they've honored one of their athletes by putting him up here in the nighttime sky. So I guess if we were naming constellations today, Auriga might be somebody like, I don't know, LeBron James, Patrick Mahomes, somebody along those lines. But the Greek people beat us to it, so we have Auriga up in the sky instead. And that takes us halfway around the winter circle already. We have Rigel in Orion, Aldebaran in Taurus, Capella in Auriga, and from there we're going to come over to these two stars over here. Now, only one of these is a first magnitude star. It's that one there, Pollux. This one is called Castor, and some of you may recognize the names of Castor and Pollux. Those are the Gemini twins, and it did all the lines again. Let me get rid of that if I can. It's not going to let me. And this is the constellation Gemini. Those two bright stars mark the, I don't know why it's doing that. Maybe I have to get closer. No, still doing it. Oh, well, fun with computer programs. The Gemini twins. Castor is a second magnitude star. It's like number 28 or 29. It's very close to being a first magnitude star. Pollux is number 24, so it's next to Bellatrix over here. It's the dimmest first magnitude star of the circle, but that doesn't mean it's not impressive. I see these guys as a couple of stick figures. Pollux is a little easier to see. These two stars are their heads. The body of Pollux comes down like that. His legs are right here. Castor has a much longer body. His legs are right here. And then their arms are a single line going across like this, as if they have their arms around each other's shoulders. Now, being twins, it is easy to mix these guys up, but there's actually a very simple way to remember which twin is which. You can remember that Capella begins with the letter C. Sorry about that. Let me get this up here again. Capella begins with the letter C, and so does Castor. So the two C's are on the same side of the circle. And Pollux begins with the letter P, and so does the next bright star we come to down here. It's called Procyon. And we find Procyon in the constellation of Canis Minor, the little dog, which is in the sky above Canis Major, the big dog. So Procyon and the little dog literally rise in the night sky before the big dog. Now, these two guys are hunting dogs. They're the companions of Orion the hunter as he battles Taurus the bull. So we actually have an entire hunt scene up in this part of the sky. However, to give Orion two dogs, the Greek people did have to fudge things a little bit. And because of that, the little dog is my favorite constellation in the entire nighttime sky. The little dog is Procyon, and that star there. That's it. I don't know, maybe it was a wiener dog or something. I think it looks more like a galactic pencil myself, but hey, the Greek people really wanted Orion to have a second dog, so that's why they made this constellation out of two stars, which brings up a good point for when you look at the nighttime sky. Keep in mind, all I'm doing here this evening is showing you how myself and the program I'm using, which is called Stellarium, show these things in the nighttime sky. But really, we today don't use constellations in the same manner as the Greek people. All the Greek people had to keep track of was stuff they could see with their eyes, playing dot to dot with the stars got them by just fine. However, today, we astronomers have to find really faint stuff in every last little nook and cranny of the sky. And you can see it's a big place. So because of that, the Greek astronomers today have actually divided the entire sky into 88 parts, and each part is represented by a constellation. That way, any object, no matter how faint, will fall somewhere inside the boundaries of a constellation. It's kind of like when you look at a map of the United States. This is a big country, so we've divided it in 50 states. That way, any town, no matter how small, will fall somewhere inside the boundaries of a state. So what does that mean for you and I? Let's take a look at Auriga up here for an example. I'm going to turn them around like that, if I can. There we go. Auriga isn't these stars right here. Auriga is this entire part of the sky I'm closing in with my cursor. Matter of fact, I think I can do this. Yes. There we go. Yeah. So now I can do that. Auriga is this entire part of the sky right here. But what that really means is it doesn't matter how you play dot to dot with those stars. You can do whatever you want to them to make those something you can remember as the charioteer. For example, I think of him as a superstar athlete. So I see a big star up here. And I actually moved my button there, but I see a big star up here in this part of the sky, and that's how I remember the charioteer. And you guys can do the same thing. I actually think that's one of the most fun parts of looking at the nighttime sky, is basically doing what the ancient Greek people did, and that's use your imagination to create patterns to help you remember where this stuff is. So keep that in mind when you go out to look at the nighttime sky. Okay, we are almost done with our circle. We started with Rigel and Orion. We came up to Aldebaran in Taurus, up to Capella in Auriga, over to Castor and Pollux in Gemini, down to Procyon in Canis Minor. Our final stop is going to be the #1 star in the sky. Next to the sun, this is the brightest star in the sky at any time throughout the year, and it's called Sirius. And yes, it's one Sirius star. But as you can see, this Sirius is spelled S-I-R-I-U-S, like the character in the Harry Potter movies or the satellite radio company. And we do sometimes call Sirius the dog star because we find it in Canis Major, our big dog. Now, this is a very good way to draw the dog. Some people think he looks more like that. I think it's a little ridiculous myself. But keep in mind, I actually know 4 different ways you can draw this dog in this group of stars. But I'm not going to show you the other 3 ways because I'm going to let you use your own imagination and make your own dog out of those stars. And the reason I said it's for 11:30 is the tail of the dog has cleared the horizon by that. Now, the winter circle here, Taurus is up at sunset. Orion is up by about 9 o'clock now. As winter moves along, these will be rising higher and higher in the nighttime sky. But let's go around the circle one last time. Make sure you got these down. We have Rigel in Orion, Aldebaran in Taurus, Capella in Auriga, Castor and Pollux in Gemini, Procyon in Canis Minor, the little dog, and Sirius in Canis Major, the big dog. And of course, you don't want to forget Betelgeuse and Bellatrix. So that's 1, 2, 3, 4, 5, 6, 7, 8 first magnitude stars. I thought it was 9. No big deal. So that is the winter circle that you can go out and look up at. If you really don't need a lot of fancy equipment to look at the winter circle, there's all sorts of interesting things to see in this part of the sky. After the show, in the comments, I will post a link to one of my favorite websites, which is called skymaps.com. If you go to skymaps.com, you can get a PDF of the current night sky that you can then use to go out and look at the nighttime sky. It's what we pass out at the planetarium shows, and it's just a great resource. Not only shows you objects of interest, shows you upcoming events in the nighttime sky, and it shows you some deep sky objects you can look at with telescopes and binoculars as well. Speaking of events, let me roll back time a bit to about That's too late. That's 6:30. Let's go back to, let's go to 7 o'clock, or yeah, 7 o'clock right there. And we're going to move over to the southwestern sky because you'll see that Mars is up, the moon is up. You can't really tell on this program too well, but right now we have a crescent moon up in the nighttime sky. But the big stars going on right now are here in the southwestern sky. Tonight, on the other side of all these stupid clouds that are out there, two planets are really close together, Jupiter and Saturn in the nighttime sky. Jupiter is the fourth brightest object in the entire nighttime sky. The only three things brighter are the sun and the moon, obviously, and our nearest neighbor, the planet Venus, which is in our very early morning sky. Saturn is our sixth brightest object in the sky. The thing that's in between Saturn and Jupiter is Mars, which is up there, like I said, on the other side of the moon. Where are you? There's Mars over there. But we're going to talk about Saturn and Jupiter, and this is called the Great Conjunction. Some of you may have seen me on WFMJ, where it was referred to as the Star of Bethlehem. It's not quite that. I will explain that in a minute. And I'm just going to do this and that. Make sure I'm on this. Yes. F5. There we go. So here we are looking at the Great Conjunction. This is happens every 20 years. And the reason for that is the Earth goes around the sun every year. Jupiter goes around every 12 years, basically, 11.86. And Saturn takes nearly 30 years to go around. So we go around, Jupiter goes around once, and it takes 20 years for Jupiter and Saturn to line up. So the last time they were in conjunction like this was the year 2000, but they weren't this close in the sky, in our nighttime sky. Now, keep in mind, they are still nearly 900 million miles apart from one another in real life. They just happen to be lying in the same direction in our nighttime sky. The last time they were as close as they are now was in the year 1623. That was only a few years after Galileo first used a telescope to look at the nighttime sky to begin with. However, in 1623, the planets were very, very close to the sun, so probably nobody got to see that conjunction very well because they were lost in the glare of the sun. The last time we were able to see them this close on Earth was the year 1226. They will line up again in 2040. They won't be this close. The next time they'll be this close will be in 2080. So this is going to be a once in a lifetime event. It occurs on Monday night, is going to be their closest approach for us to look at. Now, the reason people are calling this the Star of Bethlehem is because in the Bible, of course, the wise men from afar came to visit Bethlehem and the baby Jesus, and they were guided by a star. But it is a wonder, if there was a bright star in the sky, why nobody else other than these three guys figured out to come over. Well, in the Bible, now, I will tell you, I am not a biblical scholar. I only know this stuff because I've been in planetariums for 23 years, and I have done a number of Star of Bethlehem shows in 23 years in planetaria. But the name that the Bible gives the wise men is Magi. And translated, that can mean either wise men or astrologers. And they were from the Far East. They practiced Zoroastrianism, I think is the name of the term. Now, early Christians despised astrology. They couldn't stand it. That's why they called them wise men in translations rather than astrologers, because they hated that stuff. And what they think might have set them off wasn't Jupiter and Saturn, but around 3 BC, Venus, which I said is the third brightest planet, and Jupiter, which is the fourth brightest planet, made a conjunction around the star Rigel in the constellation Leo the Lion, Regulus in the constellation Leo the Lion. They associated Leo the Lion with kings. They associated the star Regulus with royalty, and the two brightest objects were, first they did it once in the fall, which set them out on their journey, and then they did it again in the spring in the early morning sky. So they took this as a sign and led them to the birthplace of kings, apparently. None of that's mentioned in the Bible. We know this by running simulations of the planets at that time, and this is our best guess as to what they were looking at. So it wasn't these two guys, but because it is occurring when it is occurring, a lot of people are saying that sort of thing in the nighttime sky. So as we look at these, you'll see that Saturn and Jupiter on the 16th were very near the moon. They were even closer tonight. They're almost right on top of each other. The Great Conjunction happens on December 21st. They're going to be 1/10 of a degree apart, 1 degree apart from each other, which means you'll have a very hard time with just your eyes separating them out in the sky. But with a telescope and binocular, you'll be able to. Now, if the weather is like it is tonight here in Youngstown, you might not have the best view of this event on Monday. I hear Wednesday's going to be pretty good, and if you look here on December 23rd, you still can see them. The thing is, though, they are getting lower and lower to the horizon because the sun is also catching up with them. So we're only going to have about a week after to catch them in very close proximity. So hope over the next week or 10 days we get some clear skies so we can take a look at these things in the nighttime sky. Since we haven't been very lucky with clear skies, I have a telescope sitting at work ready to come home to look at this, but haven't been much need for me to dig it out and bring it home because, Youngstown, and also 6 inches of snow on the ground. But, that's how it goes. So I got some images here from the web. These come from a website called earthsky.com. Amateur astronomers are sharing their pictures, and they're putting up some of the really good ones. This one comes from a photographer named Lauren Zenkova. She was in Ventura, California on December 15th, and she caught the brand new crescent moon down there at the bottom, and she also caught Jupiter and Saturn up above to the one side. That is a very pretty shot with the ocean there. I really like that one. This one was taken in Fort Worth, Texas by Matt Lance. And I like this one because the moon is closer. This one was a day later and the moon's climbing closer. And he's put a zoom on it and you can just see a couple of dots around Jupiter there. We'll get to that in a moment. That was a really cool shot that he took as well. I really like this one too. I like Oceans and Stars. This one was taken by Yaroslav Kuznetsov from Peggy's Cove, Nova Scotia in Canada. And this is about as far east as you can get in the North American continent. And he caught them going back to the west there with the lighthouse in the background. The reason they look kind of fuzzy is he did a time exposure on that. That's why he got all the light on the lighthouse. And they're showing up quite well in the background as well. That was also on the 16th. This one was taken in North Carolina on the 16th as well. Notice they're in different positions. I think the David Scharf here actually rotated the image to fit the thing a little bit better. He might have superimposed these two. I don't think they were quite close enough on December 16th to get them both in the same eyepiece, unless he had a really wide view eyepiece that it took. But you can see 4 moons of Jupiter right there. I don't know which are which, but the 4 major moons that you can see easily with any telescope are Europa, Io, Ganymede, and Callisto. I'm assuming this one would be Callisto because it's the furthest away, but you can't really tell as they're orbiting around Jupiter there. And you can see the rings of Saturn very clearly. and some of the cloud patterns on both Jupiter and Saturn. Now, keep in mind, these are nearly 100 million miles apart from one another, but they are both very easy to see in the nighttime sky. And this one I just grabbed today. This comes from a gentleman named Ron Burkett in Trussville, Alabama, that was just taken yesterday. And this was done with a single eyepiece. He had a 40 millimeter eyepiece. Unfortunately, my source did not list what size telescope he had, but he actually set up his telescope and got both objects in the eyepiece last night. A 40 millimeter is a rather wide field. That's why you're not seeing too much detail on Jupiter and Saturn, because it's a wide field. To get more detailed, you have to use a smaller millimeter eyepiece, like a 25 or a 15. When you do that, though, you also narrow your field of view, and you might not be able to get both in. On Monday, though, that's not going to be a problem. They're going to be so close together, a tenth of a degree apart from one another, you will be able to see both exquisite detail and both of them in the eyepiece at the same time. Now, that's what we expect to happen, but knowing us, this is what's going to happen because, Youngstown. And actually winter in the United States as well. And of course, the headline after that will be this. Astronomers to meteorologists, you suck. So let's hope that doesn't happen. And we do get some good skies as we go through there. Now, on Monday at 5:02 a.m., there is another event going on. 5:02 a.m. on Monday is the official winter solstice, the shortest day of the year. Actually, because of our latitude at 40 degrees north latitude, that actually happens a few days ahead because we are so far north, but we are in the darkest nights of the year. And it's actually no coincidence that Christmas is celebrated at this time of the year. Nobody knows for certain what season Jesus was born in. The only clue comes from Luke, who said that there were shepherds keeping watch over their flocks at night. Usually that only happened in the spring when new lambs were being born, but scholars disagree on that. They might have been out in the field for some other reason. So there was nothing in the season. So actually, the early Christians co-opted a Roman holiday that was called the birthday of the newborn sun, S-U-N, which was a solstice festival that followed the Roman festival of Saturnalia. Saturnalia was their winter solstice festival. So they took S-U-N and changed it to S-O-N and made December 25th Christmas Day for their patron saint. So they do a lot of that stuff other than Easter, which is well documented with Passover and the New Testament. We really don't have a lot of firm dates. So most of the festivals we assign, we do by co-opting pagan holidays and making them Christian. So that's just the way things go. But we're going to talk about the Earth seasons here. As we mentioned last week, we talked about seasons then too. Some people think we are further away from the sun at this time and closer in the summer, but the opposite is true. We are going to be at our closest approach to the sun on January 4th. So what really causes the seasons is the tilt of the Earth. Right now, we are over here. The northern part of our planet is tipped away from the sun, but our friends down in the southern hemisphere actually are having summer right now. If you go to Australia, you can go to the beach and then celebrate Christmas at the same time because they have Christmas in summertime down there. Now, we are tipped over 23 and a half degrees from vertical. So that means we get less sun. There are two major factors that cause our seasons. This tilt means that the sun is much lower in our sky, and that creates two things. First off, in June, it is much higher in the sky. When it's much higher in the sky, it stays up for much longer in the sky. So we actually have 6 more hours of daylight in the summertime than we do in the wintertime. When the sun's up for longer, of course, it can heat up the Earth longer. And so we get more daylight. But there's another factor going on there too. When we look at the sun rays in June, when we are tipped toward the sun, and the sun rays in December, when we are tipped away from the sun, they come in at different angles. So in summer, the rays are much more intense because they're covering a smaller area. In the wintertime, they come in at an angle. I don't know if you've noticed those very few days when we're out driving around and the sun is out. Have you noticed you can't get the sun out of your eyes? That's because it's sitting at such a low area. Now, this is the same amount of sunlight. It's just spread over a much larger area. And when that happens, you see much less of, you get much less energy. So the sun is not as efficient in heating up the ground as well. So the amount of sunlight due to how high it is in the sky and the angle the sunlight hits us are the two things that affect our seasons. Now, we don't have our very coldest days. Hold on one second here. I gotta get out of that because I'm going to have a very bright face if I don't. Yeah, there we go. Okay. So, get rid of that too. There we go. So, because that has to do with the polar ice caps. The polar ice caps don't immediately freeze up on the first day of winter. It takes a while for the ice to build up. When the ice builds up, that affects the Arctic air masses, and then we get the colder air in a lag in January and February. In the summer, it doesn't happen right on June that the polar ice caps shrink back up. We get a lag, and in July and August, we get our hottest days because of the factors with that too. So those are the two things that affect our seasons when we look out there. So there we go. I've managed to talk for 45 minutes, which is pretty good considering I was doing solo. We thank all of you very much for this last year. We know this has been trying for you guys as it's been trying for us. When we are trying to, we would love to have you in the planetarium, but just can't at this time of the year. So we hope when we do get back in the planetarium, you can join us again. Right now, that's looking like it's probably going to be the fall when we get back in there. We'll see how things go with the vaccination. Until then, we, like I said at the beginning of the show, this is our last Keep Looking Up of 2020. And just like we do with our public shows in the planetarium, we will be taking January off from Keep Looking Up as the new semester starting up and we're getting settled back in to our routine with the spring semester. But we will be back in early February with new shows for you. Our student employees will be back with you as well. Until then, please have a fantastic holiday season, no matter which holidays you're celebrating right now. Please stay healthy, stay safe, wear a mask when you go outside because we want you back in the planetarium when we start up again. And we can't do that if you get sick and have to, So you're a great audience. Thank you very much for joining us. And we look forward to seeing you again in 2021. And until then, keep looking up.